Okay, now we're going to actually go through the entire proofs. We're not going to be given any statements. We're going to provide our statements, the reasons. We're going to provide everything here. So let's give this a shot. So the first problem, we're given that this is true. We want to prove that this is true. So our first statement, number one, is always that given statement. 3x plus 1 is equal to negative 14. And the reasoning behind that is we're told. That was our given. Statement number two is, okay, what are we going to do now? And in order to solve this, let's see, the first thing I would do is move that plus 1 over. And the way that we're going to move plus 1 is by subtracting 1 to both sides. When I subtract 1 from the left side, the 1's gone. When I subtract 1 from the right side, I now have negative 15. And again, that would be the subtraction property of equality. Okay, next up, if 3x is equal to negative 15, I know that I can divide by 3, and that gives me x is equal to negative 5. And again, what I did there was divide both sides by 3, so that would be the division property. And notice that x equals negative 5 is actually what I was trying to prove, so I'm finished. Number 2, again, copy down the given statement, and that the reason for that will be that it is given. And then for step 2, you'll ask yourself, okay, well, what would I do to actually solve that? And most of you, the first thing you would do is actually go through and use your distributive property. 2 times x would be 2x, and 2 times negative 9 is a negative 18. Bring down equals, bring down negative 10. And again, the reasoning behind that was distributive property. Now to solve that, we now 2x minus 18, we've got to isolate the x, so let's move our minus 18 over first. So to move minus 18, we're going to add 18 to both sides. That's going to be your addition property of equality. So add 18 to the left side, and the negative 18 is gone. Add 18 to the right side, negative 10 and 18 is 8. So again, that is your addition property of equality. And that brings you down to your fourth and last step. To get rid of the 2, to isolate x, we're going to divide both sides by 2, divide the left side by 2, and you're left with the x, and then 8 divided by 2 would be 4. And again, that's what you were trying to prove. The reason you can divide both sides by 2 would again be the division property of equality. Okay, number 3. The first statement is always your given, so I'm given that m divided by negative 3 plus 10 is equal to negative 1. And again, the reasoning for that would be that is what you're given. Step number 2, always try to combine your constant terms. So I'm going to move my plus 10 to the right side by subtracting 10. So we're going to subtract 10 from both sides. I now have m over negative 3. Subtract 10 on the left side, and the 10 is gone. Subtract 10 on the right side, negative 1 minus 10 would be a negative 11. Again, that is the subtraction property of equality. Step number 3, and this should be our last step. To get m by itself, you have divided by negative 3, so I'm going to multiply both sides by negative 3. When I do that, the negative 3 is gone on the left side. When you multiply the right side by negative 3, you get 33. And again, the reasoning behind that was the multiplication property of equality. And notice that m equals 33 was what you were trying to prove, so you are finished there. Number 4. Okay, number 4 is just a little bit different because I want to point out that on number 4, the whole left side is being divided by 2. So we're going to have to start out with a little bit different strategy here. So number 1 is still a given though. 5y minus 2 all divided by 2 is 7, and that is your given. But we have 2 options. We can either use distributive property, which I wouldn't suggest here. You could divide each of these by 2. I wouldn't do that. I would go ahead and get rid of division by 2 by multiplying by 2. So we're going to multiply the left side by 2 and multiply the right side by 2. That property is going to be your multiplication property of equality. But when you do, on the left side, the 2 will be gone. On the right side, you'll have 7 times 2, which is 14. Again, the multiplication property of equality. And from here on out, it looks just like the other problems that we've been working. Step number 3, to move minus 1, we're going to add 1. When you add 1 to the left side, the minus 1 is gone. Add 1 to the right side, you get 15. That will be the addition property. And then the fourth and last step, to get y by itself, we're going to divide by 5. Divide the left side by 5, and it's gone. Divide the right side by 5, and you get 3. And that will be the division property. And you can check, and y equals 3 is what we were trying to prove. The next one, you're given that 10k minus 4 is equal to 2k minus 20. And that is, again, what you are given. We're trying to prove that k is negative 2. Step number 2, let's combine our k's. To do that, I'm going to move my 2k's to the left side by subtracting. When I subtract 2k's from 10k's, I now have 8k's. Bring down the minus 4. 2k's is now gone. Bring down the minus 20. And again, I subtracted, so that would be your subtraction property. Step number 3, I'm now going to get rid of the minus 4 by moving it to the right side. So my 8k is going to stay. My equal sign is staying. So I'm adding 4 to both sides. So negative 20 turns into negative 16. That is the addition property. And finally, step number 4, to get rid of the 8, we're going to divide both sides by 8. I'm left with a k on the left side and a negative 2 on the right side. And I did so by the division property. And you can check, and k equals negative 2 is what I was trying to solve or prove. Number 6. Step number 1, we are given that 5n minus 42 is equal to 12n. And that is, again, the given statement. I'm going to go ahead and move my n's. Just to make these a little bit different, I'm going to move my 5n's to the right side. So I'm left with negative 42 on the left side. And I'm going to subtract 5n's, and that will give me 7n. So I did so using the subtraction property. Step number 3, to get n by itself, I'll now divide by 7. So when I divide negative 42 by 7, it gives me negative 6. And the right side, I have just my n, and that would, again, be the division property. Okay, last step. I'm trying to prove that n equals negative 6, and I have negative 6 equals n. So I've got to change signs there, or change sides. So I can flip that around. If negative 6 is equal to n, then I know that n is equal to negative 6 by the symmetric property. So anytime you need to flip-flop your x equals and or some number equals x and x equals some number, it'll always be the symmetric property. Okay, number 7. Step number 1, you are given that negative 8, parentheses, w plus 1, is equal to negative 5, parentheses, w plus 10. And that is the given statement. And anytime you have parentheses, you're always wanting to get rid of those parentheses first. So let's negative 8 times w and negative 8 times positive 1. And negative 5 times w and negative 5 times 10. That will be my distributive property. And after that distributive property, look and see if there's any like terms on the same sides, and there are not. So let's move our w's. Let's get rid of minus 5w by adding 5w. So when I add it over here, I now have negative 3w. Bring down the negative 8. The negative 5w is gone, so it equals negative 50. And I did that by adding 5w. So that's going to be my addition property. Okay, step number 4, let's combine our negative 8 and our negative 50. I'm going to move minus 8 by adding 8. I'm left with negative 3w on the left side. When I add 8, I now have negative 42. Negative 50 plus 8 is negative 42, and that would be my addition property. And then finally, my last step, I've got to get rid of that negative 3. Since negative 3 is being multiplied by w, I'm going to divide by negative 3. Negative 42 divided by negative 3 is a 14. And that would be, since I divided, that would be my division property. And you can always double check and make sure you did prove what you were trying to prove. And the last one. Step number 1 is let's write down what we are given. That'd be 14 minus 2 parentheses x plus 8 equals 5x minus parentheses 3x minus 34. And that is given. Always look and see if you have parentheses, if we can distribute. So bring down 14, we're going to distribute our negative 2. Negative 2 times x, and negative 2 times 8 is a negative 16. On the other side, we're going to distribute, this is still distributive property, we're distributing a negative 1. Negative 1 times 3x is negative 3x. Negative 1 times a negative 34 is a positive 34. Again, we just used the distributive property. Okay, step number 3. I noticed that I have some like terms on the left side. 14 and negative 16 are like terms. I also have some like terms on the right side, and that would be the 5x and the 3x. So this next step, I'm going to combine those. I'm going to leave my negative 2x on the left side, and I'm combining 14 positive and a negative 16, that'd be a negative 2. On the right side, I'm combining my 5x and negative 3x, which is 2x. Everything else stays the same. So again, there's two different things you can call this. You can call it either simplifying, or you can say you combine like terms. Just tell, again, the reasons is why could you do that? And the reason I could do that is I was just simplifying. I was combining like terms. Either one of those answers would be fine. Now we're going to move some terms. I'm going to move my 2x right here to the left side. Since it's a positive 2x, I'm going to subtract. So when I subtract 2x, I now have negative 4x. The 2x's are gone on the other side, and I'm left with 34. Since I subtracted 2x, that would be the subtraction property. Step number 5, I'm now going to move my minus 2 over to combine with my 34. When I move minus 2, I do so by adding 2, and that would give me 36, and that would be my addition property. And finally, step number 6, we're going to get rid of the negative 4. Since these are being multiplied, I'm going to divide by negative 4, and that gives me negative 9, and that would be the division property of equality. And you can check x equals negative 9 is what we were trying to prove there.